All right, good afternoon. Today we're going to be picking up the NFL's Big Data Bowl on Kaggle. We have a list of things to kind of work through. We're still in the exploration phase of understanding the data that we have a little bit better and trying to get an idea of what exactly we want to look into. Just a reminder, this is a pretty open-ended um, scenario here. It's not very well defined. They give examples like you can think about, well, based on the what you have there, do run versus pass, predict the scheme, who's blitzing, things like that, or even individual players for what happens pre-snap to post-snap. And so I had a few ideas with how to go around the information here. When we went through this last time, let me just get these re-importing already. What ended up happening, because this will take a couple moments for the data to load, uh, is we saw that most of the data, there's a very complete data set, not a lot of missing information. One of the things that was being thrown off a little bit here, though, is in the rushing plays, for example, it shows the average rush per play is only 0.08 yards, and even for the pass plays, 0.17. And what's happening here is because there are a bunch of zeros filled in, it's treating those as valid responses. And so we're expecting that, sorry, uh, they're coming out with valid responses. So then it's treating those zeros as legitimate zeros versus those are just kind of placeholders. So I think if we can join the two data sets together, because I believe they are separated into two separate results here. But I need to look at the data a little bit more. So that way we can tell which of these were actually rushing plays and had rushing yards versus which ones were actually receiving plays and had receiving yards, just to kind of bring the numbers back in line. Another idea here is one of the tables had formation information. It was this, I believe, the place here. So having that, we can then break things down a little bit more of receiving yards given up by formation, by team. um, Another thing is to look at a defense and say, well, what are the percentages of snaps that they're playing in a formation versus whether it's like a one team versus another, or even a team week to week, as they start to figure out maybe what works for them as a defense or what needs to work against the opponent. So if you see a team with a defense that changes week to week, then it may depend more on who they're playing against, right, rather than the individual defensive schemes. And then there's some more fields that we can break down on. I saw there is movement data. So in motion when the ball snapped, and then motion since line set. So what those mean is that when the center hands the ball to the quarterback or snaps it to the quarterback, is that player already in motion? There are some restrictions around motion. You're allowed one player to move around, but he can't be basically sprinting across the field. There, I think it said it had to be basically running a certain speed, and then so he has to be like mostly standing still, but still moving. And then motion since line set. So if they make an adjustment to their play, if you see a whole bunch of players move around, then maybe they've audible the play and see if that has resulted in better plays. Then I just wrote out a bunch of notes for ideas for what to go down. Look at the defenses based on their formations, and then even team and player personnel, and then break down the percentage of snaps for the players, and then percentage of snaps for the players, and then the defense that they play. Another idea was to they had route ran information. So look at receiver and quarterback combinations for those to see how well they're doing on a given play. You obviously won't know the route before the ball is snapped when you're looking at it, but you can look at plays that are really effective for combinations. And then similarly, looking at some of the protection stats for the linemen, and then Even tight ends, a lot of times will do blocking, seeing how many pressures did they give up, sacks, things like that. And then once we've got those sliced and diced and have an idea of what starts to work well, then we can start looking at maybe can we do some of the prediction work of the pre-snap versus post-snap. I don't think we'll have enough time to get through it today with what I've got. I think we'll be spending quite a bit just working on doing some of the filtering and shuffling of the data to get it into the shapes that we want. And I think that's part of really trying to get to know a data set really well. So that way, then you have a good idea of what you can actually start to predict rather than just kind of throw everything at it. What you'll have then is a bunch of data and not really getting to the best factors that will actually lead to a good prediction. And it's certainly the case that even with working it, you may not get there, but you can start to eliminate things, whether they don't make sense or when you look at it, you see a lot of noise in the data, so you know not to include those. The idea is spend time in that discovery phase so that way you learn about the data better and then start to make some very base or simplistic predictions and then work your way into tougher concepts. Another thing is you may just not have enough data to support some of the predictions that you're going if you get very far into the weeds, and then keep an idea of your end in mind of this as well. You're going to present this to a non-technical audience, right? You're going to present it to people who know football very well, but don't need to know or don't know the data science side of things very well. So we want to make sure that we can still have good explainability with the model so that we can point out those key things. So if you think about this, right, it's a very large, very wide data set. You could do random forests here, but the downside to doing something like random forest is that you're not going to get good explainability in the data that you have here. And that will lead you to trouble when you're trying to put together the presentation later. So another thing here is that you're going to have a very, very wide data set if you're looking at individual players. So it may be worth it to look at these at individual teams and consider your audience for that as well. You're talking to executives from the teams. So then if you can keep it very broad to those teams, but very targeted, you would have a good chance of getting a positive response from those, right? Or you can do it where you're looking at different teams and how they're performing when they are in different formations, like who was the best in the 12 formation, who was best in the three receiver sets. Those are interesting information. And then, okay, they were the best in it. How frequently were they using it? Was it was completely, they used it maybe less than 5% of the time, but it was really effective. Should that team actually do that more, or was it they were starting to catch the defenses by surprise when they went to that formation? And then you're talking, okay, if you're a team looking at defending against this, you have to have an idea. They ran this a small amount of times. They were very effective because they threw to X player. I'm just gonna pick a team, let's say the Cincinnati Bengals, right? You have Joe Burrow as the quarterback, you have T. Higgins and Jamar Chase as your receivers. Maybe they're doing really well with a three formation set, and it's because they were bunching up T. Higgins and Chase with one another, along with their, I don't know, their third receiver. And so it was just really hard for defenses to react to that, and they should have done that more, but couldn't because there were injuries, right? And that necessarily won't show in the data set, but like I know their receivers have been injured a bunch this season and not playing, that then you can point to it and say, well, were they healthy? They would have had, the best receivers based on this. And this is with the original assumption that they were the best out of the three receiver set, but they couldn't do it because of injuries to their personnel. And so that was what limited their offense. Right. And then that's taking something that you used a very technical analysis, but being able to have it be easily understood by a very broad audience. So with that in mind, let's go into breaking these down. First thing I want to do is looking here at these rushing and receiving yards and trying to see how we can join the data sets together to find the legitimate zeros versus the non-legitimate zeros, right? go, where was, I had a tab with the the data. There we go. All right. This was player play table. Whether or not the player had a rush attempt on the play. Right. So then this is we're going to filter this. Assume this is 0, 1. Yeah, it says numeric, so I'm going to assume it's a 1. Let's see what happens now. Oh, yeah. Clean that up. Well, yeah, there we go. That's way more in line with what we were expecting, right? We were saying just by trying to take the mean here, we were getting 0.07. We cleaned it up. We found the right field to look at had rush attempt as a 1. So now we see player play receiving yards come way up. So looking at this, there's another field here. Do the same process. We're doing the player play table. The field name is add pass reception equals 1. And because that's the saying that it has a numeric field as well. I spelled it wrong. And so there we go. So the average receiving play, it was about 11 yards so far in those first 9 weeks. Then, sorry, the average completion length, right? Because they had the pass reception was for 10.9 yards, and the average rush was 4.5. Right, so we figured out to eliminate the non-zeros, but then we have a couple choices here. We can go for teams, we can go for formations to do this. So let's see here. So the team abbreviation. So this is the filter part. What I want to do is well, I'll leave these here and I will make new cells. So let's go. I want the team abbreviation field. I want the rushing yards field. Let's see, did it have the formation? Full tackles, interception. There's the route ran. Let's just search for formation. In the play data. Gotcha. So we'll not include that for now. Let's just do this. And I do group by in ABBR. There we go. Grouping by the team. What was their rushing? What was their rushing yards per play? Right, and you can start to see a difference in some of these teams averaging in the 5 yards per play range versus teams who are averaging in the 3 yards per rush range. Mean, and then there's an order by play. Keep the name. No, order by yards, and then I think it's sending equal false. Go to this. Pandas order by. Thank you. Sort values. And does this go automatically? Yes, it will. Okay. So by doing this, right, we're seeing the, let's just call them top 5 offenses per rush attempt. Right, Chicago, Las Vegas, Seattle, Jacksonville, Baltimore. And then some of the worst here: Tampa, the Rams, Indianapolis, Cincy. We can do this either way we wanted to. And then if I wanted to only select the top 5, you do it this way. This is just a slice notation. Now you end up with the top 5. And then do it the same way to get the bottom 5 by just putting a negative in here. No, sorry, that cut off the last 5. We just set this to true. And so there we go. The 5 worst rushing yards per attempt: Tampa, LA, Indy, Cincinnati, and Denver. Let's break this down a little bit more here. We did that with the passing, or sorry, with the rushing. Now let's do the same thing, but on the passing side of things. So go here, right? Add pass attempt, I believe. No, add pass reception, sorry. Yeah, that's going to be 0. Receiving yards. Okay. And so then the best per pass, right here you have Miami, Atlanta, San Fran, Buffalo, Philly. Not sure if that's what year this is, if this is this year's or last year's. Looking at here, add pass reception. So if you're just joining, breaking these down, player play is the table that we are looking at. Then this part here is filtering to make sure that they had a pass reception. So we're only going to count the rows where this criteria is met. Then I'm going through and we're grouping it by each team. So they had to have caught the ball and then split it by their teams. Then this is give me their average receiving yards. And then the last part here, sorry, there's two parts left. The sort values is saying to go in descending order by sending it to false, and then give me only the first 5 results. This is the top 5 offenses per pass receptions. And then the one up above here. So per rushing attempt, again, the same thing. So you can see a different 5 offenses here, and then the bottom of that same list. So we've done filtering out all the non-legitimate zeros. If you remember when we started, these numbers, well, we'll just show it the whole way through. So before we put in this filter, average rush yard was 0.08. And it's not, the reason why is that they've filled all the data in, so there's not a lot of null values. So it was a pass play, there's going to be 0 rush yards, right? Or there's a sack, you're going to have no pass yard or no rush yards on those. Then we have those. It's in the Tesla. One second. Okay. So yeah, we had just basically a bunch of zeros here, which then really dragged your mean down. So then we're doing this to ensure that they were actually making a rush on the play. So then you would expect to have rushing yards. And there may still be zeros this way, right? You can run, get stuffed at the line, no yards gained. That's fine. And that's why we don't filter the zeros here. We had to find a different way, and that's why there was a flag field in the data for had rushing attempt. And then we did the same process here on the pass plays. This was a bit higher to start with. I believe it was 0.7. Yeah, 0.17. But then on plays where there actually were a pass, you have 11.9 pass reception. So that's how we got to actually finding the mean. And then we just did some grouping to separate it by teams, and then sorting the values to clean it up a little bit, and then get a better idea on the best place here. So then if we wanted to, let's do it where instead of the team abbreviation, I think it's just a player ID, NFL ID. We're gonna do the same thing here. But instead of team abbreviation, it's gonna be NFL ID. You can see there's some players with a very negative rush plays here. Given that the average is this may only be that they ran 1 or 2 rushing attempts, and they were negative. So then it shows here, but the inverse would also be true, right? If a player came in and had 1 or 2 spectacular plays, they would show as the highest average here. So then this becomes a little bit more complex to do, and we need to incorporate more filtering here. So there's a couple ways to attack more of these more complex ones. Trying to see here. Look across the table, see if there's any specific information. we could use to better sort these out. This says no, no, no. Let's see here. Yeah, there's no good way to split this out. So um, what I would do here is we're going to make two columns essentially and join them together on the player ID or two groups. The idea here is to not just get their mean, but also get their count of plays, right? And then once we join them, do filtering on the count. So let's say they have to have a minimum of uh, 10 rushing attempts to appear here, right? Or um, yeah, we've about 9 weeks, so that's like saying you got about one per week during the game, and then you'll see some of these numbers come way more in line towards that average number than this. These are most likely cases where there are a few of them, or they have very few actual rush attempts. So, right, let's do this as average rush, and we're going to take the whole thing, and then I'm just going to call this num rush. It's going to be very much the same thing. Now this time, instead of mean, we do count. Do that, and let's make sure numrush came back with some data since the first time we set this up. Make sure it's working the way we intended it for it. Okay, great. And so now we have a good idea of what to expect. And then go here. And cat. Okay. So we're going to say rush that and that. And we just want to make sure. Right. Rename. Now if I do this, perfect. Then we're going to do the filter. So rush stats, num rushes greater than 10. Word values. average rush yards. Yeah, that completes so nice. So there you go. Now these are much more in line with what you would expect, right? So um, what we were seeing before, as we were showing, was it like 44, 32, something like that, 17. And now that we set the minimum number of rushes to 10, we're seeing a much more improved performance in terms of the getting to a point where you have the player with the average or highest output on an average rush, right? So you're filtering the outliers from what you're seeing there, and you get a better idea of kind of what's more expected rather than being a flash in the pan. So then this helps you get an idea of like who the best rushers are, and then I could do even more of a join. Let me go to the data set here because we can now join in. I can join in the NFL ID to player. Yeah, then I can take that and also going to concat. And this time we're going to include players. But I only want certain fields from here, so that's why I'm doing NFL ID and they called it display name. Access still is one. We're telling it to do the columns here. So that's fine. And then I'll treat this as two concats. Oh, yeah, I didn't close it before. That might have been an issue. So I did the open, but I didn't close the second one. And I'd put it there, which is incorrect. So hopefully. Okay. So let's just do pressure stat. Do this. So the first part is rush stats. We're joining it to players, and then it did not like filtering. That's fine. Let's just we can do this. Right, and then we know I want the average rush yards and the play name. The Boolean series key will be reindexed to match data frame index. Hold on, let's just do record stats. Okay. Got it. So because it was joining the index, I need to give it keys. And then players, spot, NFL ID to join those. Stats, index. I think it's just that way. Yeah. Okay. It's just because I change series index to column, reset index. Run, rename Nexus. And I'll call this NFL ID to match the other one. And then that should eliminate the need here to use the keys. Now we got rusher stats. Hold on a second. Okay, so these are happening because we didn't find the player. What a rush stats. We had how many? 271 rows, right? Gotcha. So it needs to be an inner join. That's why. I think it defaults to an outer. If I get it right. Yes. So join equals inner. And what an inner join is that something that is one table must be in the other for them to come through. You see here, rusher stats had 271 rows, but then we got to rusher stats before it was having about 1,700. Now we've got exactly those 271. So great. We got all this there, and then do this. Pressure stats now gives us why are these coming back with all negative? Or sorry, not negative. Defensive players or rushes. Did JJ Watt really have 11 rushes? But Corey Peters have 38? No, the two NFL IDs don't match. So he's that's NFL ID. Players. NFL ID. I hope I did that correctly. I did not. All right. So he's is looking for the list. No. That's not what I was expecting. Okay. So it might need to just be merge here because they have too many different columns. I'm going to say left, ooh, typo there, right equals players. Instead of join, it's saying how still inner. On equals NFL ID. Try this. Use 70, and when I filter these, this would be more of what I was expecting. Now we're not getting defensive players. We're starting to get some of the offensive players. So I'm assuming these are now the right names pointing there. So now we've incorporated player information or more complete player information to that. And then next step here the formation information. So if I do this, can I just say NFL B and display name? With the table getting overly large. No, I still have to figure that out. So put that here to get only ID and name from players table. Now what I want to do, I want to get the formation information, but I don't want to pull in all the plays. So I'm going to do this kind of in 2 steps. So I'm going to call this play formation. And so I want to take plays, play ID, and what's it called? Offense formation group by the ID. The error. Okay, let's break this into pieces. I need it to be this way. Great. So that may have been the issue here too. So and this should be the same. Play formation. The play ID is not unique across games. So it's a for each. And that's what we're doing. So then this becomes game ID, play ID, And so there you go. There's now 196. I just reset this. Yeah, I needed the count to pull it together. Then rename like this. Oh, we'll just leave it as offense. Make sure we may need that. Right, it should be reset. Index. Equals. And this is just the list of names. And so there we go. Now we have every game, the play ID for that game, and then the formation. You take this here, make sure that that goes. Yes, great. So you go to retro stats and see. Yeah, we only display them now. So this to do is done. And now we're going to go. Oh, brushing stats. We want to do merge. We need to go back even further because I don't have the play. In the player data. Yeah, so this. Let me change this slightly. Oh, no, I'll need to change this, the whole thing. Okay, so leave that there. Let's do this. I'm going to copy this down further just so we don't lose what was here. And so we see basically there are 10 best Best average rush result with minimum 10 plays, right? And then we want to now add formation to play results. Then figure out best rusher by best average rush by. Now we need to change this slightly because what was happening is we were taking just getting the mean from before. That won't work when you do it this way. So we need to change this slightly to make it work. We still need player play. We're going to call this player rushes. We need that they had a rush. We need to group by the NFL ID. We also need the game ID. We don't need to sort. Putting some here is just still fine. What was it rushing? Yards. Yeah, I want to just see what comes out of player rushes. Their games. Rushing yards in the game. I also need count. Can we do both? Yeah, let me give me the overall count. Pandas. Gotcha. Okay. Oh, this is player rush yards. And then player rush attempts. Yeah, player rush yards. Uh, Figure that out. Okay, so then we see players with multiple rushes across games. It's fine. That's going to matter when we do the join for these. So then this, now we've got that's, and so this should be player rush yards, player rush attempts. We probably need this to change to merge. Left, right, now is inner and on FL ID, close the game ID. And can we just see how that comes out? So player rush yards, that shouldn't have changed. Player rush stats. Great. I don't need to rename any indexes or anything like that. Let's just make sure we're getting all the rows that we should. So that's yards. And that's attempts. And 1094 at the end. So we're good there. And now I want to take the rush stats. This should be the player rush stats. The player's name and display name, and join it on the NFL ID. Now now there we go. So we have a more complete list. Of name, ID, display name. There's the formation. We need this part to come in. Yeah, I didn't do that. Okay. So play formation. Great. And so now could have rush data and PD merge. Left is the rusher stats. Right is the play formation. How inner. And the on game ID. Right, so we have game ID in the play formation. Is it in rusher stats still? Perfect. You should probably join us sooner in the play. We have the play ID here. Yep. The player play has the play ID all the way through. And then when we get to the formation, you just need the play ID. Game ID is actually irrelevant here. It's not adding anything, it makes it take longer. I have to change this to also include play ID here. Play ID this issue. That should look slightly different, but then rush data. Oh, there. And so now if we wanted to break it down, we could do filtering based on display name, the offenses formation. Sorry, the display name is the player name, and then the offenses formation. And you can do some math to get the average rush for that. So let's do display name, offense formation. Why did that? I know it's going to filter. Rushing yards. And the count. Actually, because I'm grouping by count, this should never, it would always be one. We can go here to do the rush yards. Count's not going to exist. Real quick sanity check because I made some changes. We want player rush yards. The 1,094 rows. About rusher stats. 1,094 rows, plus we have the names come in. Play. 8,900, but then when I do the join here, we're only getting 800 rows. So I'm losing something along the way. The only thing I'm matching is the play ID. Rusher stats. I'm losing about 150 rows here. Basically out of time. Got about, yeah, lost about 150 rows. Dev asks, what are we doing here? We're going over the data for the 2025 Big Data Bowl from Kaggle. What I was trying to do was get a breakdown of rushing yards by player formation and their rush yards and the number of attempts. Originally, before I brought in the formation information, it was fairly straightforward here. You can see here most of the information is pretty easy to get to, but then because we're bringing in the formation information, which is in the play table, not in the player data table, we need to go up and bring some more information all the way through here. So for the player play, we now need to keep the player ID, game ID, and the play ID, as well as the rush information, and then join those together. And right now I'm looking at when I did the final merge here from the list of plays, all I kept was the ID and the offense formation. I lost a number of rows here. So we're going from, it was like 1,054 down to 874. So I lost about 175 rows or more than 20% of my data. So we need to go through and figure out why that's occurring. So if I look at, I need to figure out what rows are in this rusher stats that are not in the play formation. Go rusher stats here, play ID, counts. It should just tell me so there are some duplicates in that 1070. So because it's an inner join, we'll lose some. So do I have like 170 duplicates? Why would there be a play with two rushers? Two people with a rush stat. Part of what I need to figure out here. I just do first 10. Let's see if this is something that regularly occurs. Yeah, it is. So in the rusher stats table, the player had multiple play IDs that had a rush. Oh, that's because play ID is not unique for a game. And so the play formation plays this play. I'm assuming play also has the game ID. Plays does have the game ID. And that's part of what was missing here. So I need to make sure that when I join those, I still have those together. Game ID, play ID, and then I have to pass this all the way through. Again, game ID, play ID, reset the index, game ID, play ID. Then when I do the join, it needs game ID and play ID as well. Now, when I get to why did I lose even more rows? I only have 266. Levels. 1094. Rush data. If I do play formation, I should also have the same thing. There's going to be way more rows, but that's fine. I'm almost out of time today, so I'm going to just quickly leave myself some notes to pick this up for next time, because what we need to do is look into more of why we are losing rows here when we join these two tables. We should see game ID and play ID mirrored across them, but when I join those together, I'm only getting 266 rows at the end, when we should have about 1,000 or so rows. So the information, or the hang up here is when we're joining the formation information to the rush information. So let's leave this as a note for next time. To find out why formation and rusher that's join is massively reducing rows. To, what was that, 260? 266. And then the idea here is that we're trying to get an idea of who the best performers are by different formation types in terms of rushing. We would do the same for passing. From there, we can try and get an idea of the outcome of the play based on the player and formation information. So the next time for this, I'll probably be at some point over the weekend. Later in the evenings, I'll go through this and we'll try and get a better idea of what's happening, why we're losing about 3/4 of our data here, and then go into trying to do some of the prediction information, joining these together to at least hopefully get an idea of predicting even just the average run outcome or expectation based on a play. So what I'll do here is we'll stop for today. I'll set this up and we'll probably do Saturday evening time after I've got my kids down for the night. Go spend more time doing some of the dev here or data exploration and really trying to get a better understanding of what's happening, not just with this, but how the data set comes together. So that way we can start to work on some of the predictive models. For those of you that came, thank you. And then for those of you who are viewing this on YouTube after the fact, please leave a comment if you have any ideas on what you would want to see from videos like this. The idea here is that we're going to be putting together this series of doing the development work to eventually put together a submission. We have about, I think it's about 8 weeks total left. Or no, sorry, 6 weeks total left on this competition. We're going to just try and put together a presentation and slides for this, because that's what the submission criteria is. But it's pretty open-ended, so whatever we find along the way will be what I'm submitting here. So thanks for watching, and I'll see you again on Saturday.